Hey y'all, my name is Professor Kyle Evans in the Department of Arts and Entertainment Technologies at the University of Texas in Austin. And we are inside the Lab for Immersive Media, or the LIM. This space is for creating embodied immersive art experiences. We like to work with a lot of different technology in this space, including motion capture, lighting, sound design, and more. One of the projects that's really been popular is the Magic Wand. Because of how accessible it is, you can pick it up and get immediate reaction out of it. And it also really utilizes all of the different technology inside the space. So it's been a popular project for visitors and students alike, and it's a great learning tool and demo tool to teach students about the space. We want to show y'all a little bit of an under the hood, behind the scenes look at how all of this technology works, and so you can see all the different elements and how they're all connected together. The base structure of what's happening, we have a magic wand. On this magic wand, we have reflective tape that's surrounding all of these different points. Now, there's actually no technology inside this wand besides just these individual reflective points. These points are being tracked in space inside of what we call the volume by our motion capture system. So we have a Qualisys motion capture system that is sending infrared light into the space, and that light is bouncing off each one of these points, and it's able to track this wand not only in three-dimensional space X, Y, Z, but also the roll, pitch, and yaw. So we call that 6 degrees of freedom. We can take that data, and through Qualisys supplied SDK, we can send OSC data over to Unity, which we have an environment developed inside the Unity game engine. We can also use the environment like any type of game environment that you would imagine, in the sense that we can create colliders, that if I move to different positions, we can get different things that actually are responding in 3D space as I move this around inside of the room. Now, outside of the visual elements of the 3D game environment, we're also taking data from Unity and we're sending it out, including the XYZ positioning of the wand in space and also acceleration data. We're sending data over to Max MSP to collect all the information, sort it, and process it. From there, we're sending more OSC data over to Resolume Arena in order to control the lighting dynamically using pixel mapping. So as I move the wand in space and change the acceleration, we actually get a dynamic lighting that changes based on the direction the wand is moving. Additionally, Max MSP is sending out some MIDI data over to Ableton Live, where we are having some real-time sound synthesis to create dynamic sound design inside the space for spatial audio. We have a 10-channel spatial audio system inside of here, and we can synthesize sounds in real time and actually send them to all 10 channels based on the position of the wand, as well taking acceleration data and creating different types of swooshing noises to add on top of that. All those different elements come together in order to create a cohesive experience, something that's really easy that you can just pick up the wand and move around and understand and have a really cool and interesting experience. What's so great is that we can use this demo to show the students all the different aspects of the space. So if we have students interested in sound design, motion capture, or real-time 3D environments, it covers all of those things. And then ultimately, they get to create their own projects with all the technology in the space.